since this is test week, you need to have a good idea going in on what's going on with this. So let me get started with this. We're going to look at, I put this together. This is not in Buzz. This is just, I looked at it and said, okay, what skills do you need to know? What would be important taking this test that you really need to understand what to do? And so we're going to go through and just kind of demonstrate how some of these properties work with exponents. So when you get on the test and they're having you simplify these polynomials, and they're giving you a term and they want you to simplify terms, that you have some idea what's going on. If you didn't get it from the lessons, hopefully you get it here. And I'm going to have the chat window open. So if you have a question while I'm going on this, type that in the chat. I'll try to make sure I'm checking the chat regularly as we go through here, because I don't want to blow past something that you were confused about and just leave you hanging. So put something in the chat, or you can always turn on your microphone if I'm not paying attention. Hey, Mr. Brock, I had a question on. Hold on, Mr. Brock, hold on. And I'm happy to stop and go back and review something again. But at the end, I'll also have a question session in case I didn't cover something that you've already looked at in this module that you're like, hey, I didn't understand this part of it. So we'll go through that too. But let's look at what I have here, the multiplication property of exponents. And with that, starting out right here, 3 squared times 3 squared. So let's talk about 3 squared times 3 squared. What does that look like? Well, in expanded form, 3 squared is the same as 3 times 3, right? That's what it means to square something, is to multiply by itself. And so when we multiply that times another 3 squared, we're multiplying it times another 3 times 3. So what we have is 3 times 3 times 3 times 3, which is 3 multiplied by itself 4 times. So that's the same thing as 3 to the 4th power. Okay, let me demonstrate another one with 2. So 2 to the 5th would be 2 times 2 times 2 times 2 times 2. And we're multiplying that by 2 to the 3rd power. So 2 times 2 times 2. So what do we have? We have, that doesn't look like a 2. There we go. 1, 2, 3, 4, 5, 6, 7, 8 2's being multiplied times each other. So that is the same thing as 2 to the 8th power. So let's look at it with just general variable terms. X to the 4th, x times x times x times x times x squared. We have 6 x's being multiplied together, x to the 6th. So the basic general rule for when you're multiplying two exponents, the same base, right? These are both base 3. These are both base 2. The same base x. You have to have the same base. But if you have x to the a power times x to the b power, that is the same as the x to the a plus b. You just add those together. Just add them together. 2 plus 2, 3 to the 4th. 5 plus 3, 8. So 2 to the 8th. 4 plus 2, 6. So we don't have to do all of this. This is just showing how we got there. Add the two exponents together. When you multiply two with the same base with exponents, you multiply them together, add those exponents. All right, so that's how multiplication works, the multiplication property. Let's look at a power. What if we have 3 squared and we're taking that to the 3rd power? All right, so what does that look like? That looks like 3 squared times 3 squared times 3 squared, right? That's what it means to take something to the 3rd power. You multiply it by itself 3 times. So what's 3 squared? 3 times 3, right? Times another one, 3 times 3 times 3 times 3. So we end up with 3 times 3 times 3 times 3 times 3 times 3. 3 to the 6th. Because we end up with 6 3's being multiplied. Let's look at that with an x to the 4th, right? Squared. So that means we're taking an x to the 4th and multiplying it by an x to the 4th. Because we're squaring that. So that is x times x times x times x. That's one of the x to the 4th. And then another one, x times x times x times x. Another x to the 4th. We've got 8 x's being multiplied by one another. So that is the first rule that I have down here at the bottom. All right. If we have something raised to a power, then again raised to a power, so x to the power of a, now all of that raised to the power of b, same base, it's still x, and it's a times b. Look, 2 times 3 is 6. 4 times 2 is 8. So it's a times b. You just take the inside exponent and multiply it by the outside exponent. So when you simplify those, that's all you have to do. Again, you don't have to go through all of this if you remember the rule. You can do this if you can't remember. You could write it out this way, and that might help you get to the same answer. But if you remember the rule, you just multiply those. How about when we have it two things inside with the power? So let's look at that. 2 times 3 squared. So that would be the same thing as 2 times 3 times 2 times 3, right? Because it's squared. We take whatever's in there, we multiply it by itself 2 times. So if we want to rearrange that and put them together, 2 times 2 times 3 times 3, because multiplication, you can multiply in any order, right? It doesn't change things to rearrange what the order is. 2 times 3 times 2 times 3 is 2 times 2 times 3 times 3, which is basically the same thing as 2 squared times 3 squared. 2 times 3 squared, 2 squared times 3 squared. So generally with just an xy, that's the same as x times y, right? With variables, it's like put them together. You don't have to have that symbol in between. Times xy times xy. Again, we can rearrange that. That's saying x times x times x times y times y times y. Same thing, just rearranged, which is x to the third power, 3 x's. And then we have 3 y's, y to the third power. So see what happened there? Well, everything inside the parentheses, the x and the y, were all taken to the third power. It's outside the parentheses. X to the third, y to the third. So the rules, the xy to the b power would be x to the b power, y to the b power. All right. So that's 2 different ways that you could end up using that. 2 different ways. Okay. I don't see any questions on this. I'm going to move on. You can always come back to it if you have questions at the end. All right, let's look at another page. Division property of exponents. All right, so we have 3 to the 5th divided by 3 squared. So 3 to the 5th is the same thing as 3 times 3 times 3 times 3 times 3, right? 3 multiplied by itself 5 times. Divided by 3 squared. Now, I want to think about one thing. If you have 3 divided by 3, right? If we have 3 divided by 3, well, that's just the same as 1, right? It's 1 over 1. 3 divided by 3, they kind of cancel each other out because 3 divided by 3 is 1. So anytime up here that we have a 3 on top and a 3 on bottom, they cancel each other out. They're just 1. It's just changing them to a 1. And then, so there's another one. It's just a 1. So what is left? We have on top 1 times 1, we don't need to worry about. 3 times 3 times 3. 3 to the third power. And then what's left on bottom? Just 1. So that's the same thing as 3 to the third power. All right. When everything's over 1, we usually just drop the denominator. Every number can be written as over 1. You know, we count 1, 2, 3, 4, 5. It could be 1 over 1, 2 over 1, 3 over 1. You know, we don't generally write that. So it's the same thing as 3 to the third power. So let's look at another one here. 4 times 4 times 4 times 4 times 4 times 4. And one more. 1, 2, 3, 4, 5, 6, 7. Divided by 4 to the 5th. So we got 5 fourths. So again, if there's 1 on top and bottom, they cancel each other out, leaving just a 1. What's left? On top, we have 4 squared. So 4 to the 7th divided by 4 to the 5th, it's 4 squared. Let's do it with just exponents. X times X times X. Oh, I'm sorry, not exponents. I mean just variables. Variables, X to the third divided by. I wouldn't put the first. Generally, you wouldn't see first, right? X to the first is the same thing as just X. Same thing. Normally, we just see X to the third divided by X. X. One of those is going to cancel out. Leaves us with X squared. So the rule for dividing when you have exponents. Okay, Levi. Yeah, if you're having trouble hearing, x to the a divided by x to the b is x to the a minus b. Look at that. 5 minus 2 equals 3. 7 minus 5 equals 2. 3 minus 1 equals 2. You keep the same base. These have to be the same base to start with, or this doesn't even work, right? If they're not both 3s, they're not both 4s, they're not both x's, you can't simplify them. But you can simplify them this way. Keep the 3, subtract the exponents. Keep the 4, subtract the exponents. A minus B. A minus B. All right. Let's move on. All right, I want to talk about zero and negative exponents real quick. If you watched my video already, I made the review video for the test. You can watch I worked the entire practice test and show you all of that. I talked about x to the power of 0. I talked about anything to the power of 0, right? I said 2 to the power of 0 is 1. 1,000 to the power of 0 is 1. Mr. Brock to the power of 0 is 1. I think I said in the video a cat standing on top of a dog, all raised to the power of 0, equals 1, because anything raised to the power. So let's talk about why, right? I said that, but I didn't really explain why. That's what I'm doing today. 2 to the 4th divided by 2 to the 4th. Well, our rule for division, right, which we just looked at, said that if we have a dividing with the same base, both base x, we subtract, right? We subtract. So in this case, we would take the 2, and 4 minus 4 is 0. So this is 2 to the 0 power. Well, what is that if we break it out? 2 times 2 times 2 times 2 divided by 2 times 2 times 2 times 2, right? So that's 1, that's 1, that's 1. They all cancel out to 1. It all equals 1 because everything on top and bottom cancel each other out. 2 divided by 2, it all cancels out to 1. So that worked for 2 to the power of 0. What if we change that? What if we make it 904 squared divided by 904 squared? That same thing, right? 904 is going to cancel out the 904. The 904 is going to cancel out 9. Anything. It doesn't matter. We can replace this 2 with anything. If we have the same exponent, that's how we're going to get to the 0 power, right? Because you subtract. So as long as you have the same exponent, it's going to equal 1. So it doesn't matter what it is. This is just the rule. I'm just going to put a box around it. Anything. X can be anything to the power of 0, and it's going to equal 1. All right. So a little more explanation than I gave in the video, the review video, but that's how that works. We knew the division rule. We already proved that. And so it doesn't matter what the base is. I want to look at this down here. What happens when the number on bottom is larger? We have a 3 times 3 divided by a 3 times 3 times 3 times 3, right? 4, 2, so we squared, and so we got 4 of them to them. Well, this cancels out. That cancels out. We still have some 3's left, but they're on the bottom. On top, all we had left was the 1. 1 times 1. And here we have 3 times 3, which is the same as 1 over 3 squared. Well, if we use our division property, right, it said to subtract. Well, 3 squared minus 3 to the 4th, 2 minus 4, that's the same thing as 3 to the negative 2, because 2 minus 4 is a negative. So does that mean that these are equal? Let me get my giant highlighter here. 3 to the negative 2 is the same thing as 1 over 3 squared. 3 to the negative 2 power, the negative, is the same as 1 over the positive 3 squared, if it's in the bottom of the fraction. Let's look at another one. 2 divided by 2 to the 4th. 2. That's just 2 to the 1st. There's only one 2 to the 1st. 2 times 2 times 2 times 2 cancels out. We've got 1 over 2 times 2 times 2 to the 3rd. Remember, our property here says that we keep the base, subtract 1 minus 4 is negative 3. These equal each other. These equal each other. So x squared is the same as x to the negative 2 or 1 over x squared. So our rule says if we have an x that's a negative exponent, we can make that a positive exponent by moving that into the denominator, 1 over. Now, with that, I want to add something. I didn't have it typed on here. What if our x is already in the denominator and it is a negative? It works the same way. We can move it on top and make it positive. It'd be over 1, right? But we don't write the over 1. So this goes along with this rule. It's just using the opposite property. If we have x to a negative exponent, whatever the exponent is, x to a negative exponent, we can move it into the denominator of a fraction and make it positive. Likewise, if it's a negative in the denominator, we move it up to the numerator and make it positive. Let me give you a good example of when you had that. What if we had, and we had two different things. We have y squared divided by x to the negative third. And I said, simplify that. Well, our division property does not work. What way will you have to put it on the test? The test would have something like this and say simplify. It won't have these rules. These rules just help you simplify. You might have a problem like this. It might say, it might say 3y squared divided by x to the negative third. And it'll say simplify that. Well, the way you simplify that is we don't like to leave exponents as negatives. That would simplify by saying, okay, if I move this into the top, it's a positive exponent. So that would simplify to be 3x to the third. Notice I made it positive. Y squared. And generally in standard form, when you write something in standard form, you alphabetize. The x would be before the y. This is the same thing as 3y squared x third, right? But we generally put it in alphabetical order to be in standard form. So this is what the test might look for. It might say, take this term and simplify it. And it would simplify to that right there. Because we are taking the x to the negative third and we are moving it into the numerator to make it a positive exponent. We don't like to leave negative exponents when we simplify. That is not simplified if we still have a negative exponent. Likewise, if they gave you a problem that says 4x to the negative 4, and they want you to simplify that, you would say, okay, well, that's the same thing as 4 over x to the fourth. Positive exponent when it's in the denominator. So simplifying is how do we make that a positive exponent? Okay, so no, either way, it's the same principle. It just depends on if it's already in the numerator, if it's already in the denominator, what are we doing with it to make it positive? And that's the type of things you might be looking at in there. All right. Let me move on to the next page. What I have? The other thing we had in this unit, and it was right at the end, like the last lesson or two, talked about function operations. If we have functions and we're doing operations with those. And so here's 4 examples of what we had. The only thing I didn't include was the f minus. It works just like the f plus. So if we had functions f of x and g of x, it says solve f plus g of 3. F plus g of 3. This is the same thing as saying f of 3 plus g of 3. Same thing. If it's got f plus g of 3, it's just taking f of 3 plus g of 3. So you would find what is f of 3, what is g of 3. So f of 3, right, instead of x, wherever there's an x, we're putting in a 3 now. 4 times 3 plus 2. 4 times 3, we're finding f of 3, not f of x. So 4 times 3 is 12 plus 2. So f of 3 equals 14. How about g of 3? We've got to find g of 3 equals 3 minus 5. That's negative 2. So when we took f of 3 plus g of 3, it means we add these together. 14 plus a negative 2 is 12. So f plus g of 3 equals 12. Because we added those together. We added a 14 and a negative 2 and come up with a 12. Okay, let's look at multiplication. F times g of 3. Again, we have to find f of 3. And this time we're going to multiply it by g of 3. Works just like this. We're just using a different operation. So f of 3 so equals 2 times, now instead of x squared, we're going to have 3 squared plus 9. So 2 times 3 squared. What is 3 squared? 3 times 3 is 9 times 2. So that's 18 plus the 9. So 27. F of 3 equals 27, just by substituting the 3. The g of 3 equals, again, substitute. 3 minus 1 is 2. So f times g of 3 is 27 times 2. Right? We multiply them together. We multiply the two results of substituting the 3. 27 times 2, 54. Division, f divided by g. We take f of g, not g, I'm sorry, f of negative 4, and divide it by g of negative 4. Works just the same. So f of negative 4, 2 times negative 4 minus 12. 2 times negative 4 is a negative 8, and we subtract 12 more. We're at negative 20. G of negative 4 equals negative 4. We substitute in for the x, minus 1 more, negative 5. So when we divide those, we got negative 20 divided by negative 5. Negative divided by a negative is a positive. 20 divided by 5 is 4. So f divided by g of negative 4 equals positive 4. Okay, see, those all work very similarly. You're just trying to figure out what operation we're using. Plus, multiply, divide, and minus works the same way. I just didn't do a minus. You know, we could do a minus the same way. This one works a little bit differently, so I wanted to make sure and have one of these examples on here. This is given the following functions, f of x and g of x. Solve f of g of 4. So they use a bracket in there because this don't like, I mean, it could be f of g of 4, but generally they don't put a double parentheses. They'll use a bracket and then a parentheses just to differentiate. But it's the same thing as if f of g of 4. So that means we don't know what we're substituting for f because we have to solve and figure out what is g of 4. Let's find g of 4 first. So g of 4 equals 4 minus 6. So 4 minus 6 is negative 2. So this is saying, since we know g of 4 equals negative 2, this is saying, what is f of negative 2? That's what this is asking. It just doesn't tell us the negative 2. It gives us what to substitute in for 4, and we have to figure out in the function g of x what the 4 equals. So negative 2, now we know what to solve for. So f of negative 2 equals 5 times negative 2 plus 10. 5 times negative 2, negative 10. So f of g of 4 equals 0. F of g of 4. F of g of 4 equals 0. Now that would be different if this was g of f of 4. Do not expect it to be the same answer because we would put 4 in for the f this time. 5 times 4 is 20 plus 10 is 30. F of 4 would be 30. And then we would put 30 into g. 30 minus 6, that would be 24. So that would come up with a different answer. Very rare that those would be the exact same answer. It could be. There are those occasions where it just works out that way. But most of the time, I would expect to see something different. F of g would be different than g of f. So pay attention to what they're asking for when they put this on the test, because they could do that in different ways. So that's the prepared things there. I do want to show you one other thing. I didn't put, you'll notice, if we had 2x to the third plus 4x to the third. I didn't put an example like that on there. I put where we multiply them or divide them or something like that, because this is just similar terms, right? Those are like terms. We just have 6x to the thirds. We don't do anything with the exponents because we're just talking about like terms. It's like taking 2x plus 4x. Those are x to the first. You have 6x. So I didn't cover that because that's stuff we already knew. I'm just talking about when we have to take exponents and we multiply them together. What do we do with it then? Pay attention on the test because they don't use just variables. They might give you a problem like 3x squared y to the fourth z, all of that to the third power. And they would say, simplify that. And you're like, oh, goodness, how do I do that? Well, if you remember how our powers work, let me go back and find that page here real quick. The power property, if there's more than one thing inside, you apply that same exponent outside to each term inside, each term. So on this, it would be the same thing as 3 to the third power. This is one of the components there. Don't forget the constant. And then times x squared to the third power times y to the fourth to the third power times c to the third power. Each one of those things inside would be taken to the third power when you simplified that. So then you would simplify that 3 times 3 times 3, 27, x to the squared to the third power. Remember, on the power to a power, you multiply x to the sixth, y to the fourth to the third, y to the 12th, and then z to the third. So this is how this would simplify. And generally in Buzz, they're going to convert that 3 to the third power into a 27 in the answer. That might surprise me, leave a 3 to the third once, but it's the same thing as a 27. So you would have that time of thing. Now, I want to remind you, all the tests and quizzes and everything, you can use your notes. You take notes. That's why I remind you to have a spiral notebook or something to keep your notes together. So I got to thinking, what if I was taking this test? What notes would I have? Well, with Buzz, the easiest ways to get the notes is go to the end of the lesson. They have that review page, and any new equations or anything would be covered on that review page that was introduced and other things. So I said, all right, if I made myself notes, what would I do? This is what I would do. This is my Module 7 notes that I made myself. The first few lessons talked about the vocabulary, talks about a monomial, which is a polynomial with just one term. Mono is the prefix for one, right? Mono, bi, tri, 1, 2, 3. So it's a polynomial with 1, 2, or 3 terms. Beyond 3 terms, we generally just call it a polynomial. We just say polynomials. We generally don't classify it beyond trinomials. This talked about in early the degree of a term. Now, a term is just one thing. This is multiple terms when there's not an arithmetic sign. One term is just like x squared y to the third. That's one term. So an x squared y to the third, what degree is that? You add all the exponents. So this would be 2 plus 3. This is a 5th degree term. 5th degree term. The degree of a polynomial is equal to the degree of the term that has the highest degree. So there'd be multiple terms in a polynomial. Whichever term has the highest degree determines the degree of the polynomial. If we look over here, 2x to the 5th plus 4x squared y plus xy plus 7, that's a 5th degree because the largest one, 2, 3, 5, the largest one is 5th degree. So this is a 5th degree polynomial. X plus 10 is the 1st degree because x to the first is the largest. This is the 3rd degree, x squared y, because y is to the 1st power, 2 plus 1, 3rd degree. Okay, so polynomials are classified the number of terms in degree. This is a 2nd degree trinomial, 1, 2, 3 terms. 5th degree, 1, 2, 3, 4 terms. So 5th degree polynomial has 4 terms. Binomial, monomial. What else? The degree with the constant is 0. Right? If we talk about 8 is the same thing as 8x to the 0 power. It's just a 0 degree term if it's just a number. I put this up there. Anything to the 0 power. That's just my general notes from the first couple of lessons. Then I put those rules that we went over today. A to the m A to the m times a to the n is add them. Power to a power, we multiply them. Two things taken to a power. Each of those are taken to a power. Dividing, subtract. This one I didn't cover exactly. This is taken from the division, but if you have a divided by b, different. We looked at the same, like an a and an a. What we would do, a divided by b, you can break them out. It would be a to the m divided by b to the n. When they're in parentheses and both of them are taken to the power of m, that's the same thing as a to the m power divided by b to the m power. Okay, that's with the division rule. And then I looked at negative exponents, the z, and then here was the different rules. I added the minus in here. F of x plus g of x minus g of x times and divided. And then on this one, you evaluate g of x and then substitute that into f of x. So that would be my notes. And like I say, you need to take notes. If I had these on the test, it would make it so much easier. Using your notes on the test, make it simple on yourself. Right? Take advantage of being able to use notes. And when you write down notes, and you could type your notes like this if you want to, but writing them down even helps put in your memory. They do studies that if you write things down, it actually helps you remember it. And sometimes you don't even have to go back and read what you wrote because it put it in your memory when you used your pencil and actually wrote it down. It's amazing how the mind works. All right. I covered a lot of material. I threw a lot of stuff at you. Now you can throw questions at me. Any questions, other thoughts on that? I just want to give you a good rundown. And like I said, the test won't have things like this. The test will have things like this. I want you to simplify that. And so you just use these rules. These are the basic rules that you use to be able to simplify things in the test. So don't freak out on the test that, wait a minute, it doesn't look like this. No, but these are the rules you use. So have some notes, have your rules written down, have all this in front of you where you can go through it. Have some pencil and paper. Please have some pencil and paper. It's so much easier to do this on paper and then choose the answer they have in Buzz, or have to open response, type it in on Buzz. But it's so much easier to do that. But that is it. That is all I'm covering today in here. It's just a nice overall review for the test.